Hello. Science today is a complex matter, and therefore it is common that research projects are carried out by groups of people or teams rather than by single individuals. Indeed, very complex projects often require consortia where we have, if you like, groups of teams from different institutions all working together. So let's talk about collaborative research projects. A principle is that some research is best done collaboratively for a variety of reasons. For example, with collaboration, you can make best use of different specialisations held by different people from different backgrounds. So, for example, you can have a statistician and you can have a seismologist and you can have a human factors expert, and they can all do something on earthquakes together, bringing to bear their particular expertises. So, organisations also may have particular strengths, for example, research laboratories that specialise in particular things, or you might find that among similar departments in different universities, some are stronger than others, and so on. But in any case, with collaborative research, you have the benefit of the perspectives of the different people who are collaborating and their ability to enrich the whole process of throwing light on humanity's problems. So more expertise is available by collaborative research than would be available if a single individual or a very small team were doing a piece of work. But collaborative research does also have drawbacks and problems. It requires coordination, and with a large consortium, that can be extremely time-consuming and challenging. High volumes of correspondence. I can recall, for example, coordinating a large research project, and 1,500 emails arrived in 1 year connected with the project. And decisions often have to be taken collectively among the various members of the project, and that can take time and effort as well, as does sharing information between the project participants. I can recall an old hand at this process saying to me at one stage, David, you know, it's 70% democracy and 30% pure fascism. At a certain point, you have to actually impose your views on things just to get things done. But for the rest of the time, you also have to allow people to have their say and their input into the project, because it is about collaboration. So we tend to have in collaborative research projects frequent meetings, and they often involve long-distance travel where we might need to go to a different country to participate in the meeting, maybe for a couple of days, with all the extra time required to do the travelling. Another problem might be that in a consortium we have institutions that don't pull their weight. They get the money, but they don't do enough. Collaboration also can drag a project down to the lowest common denominator and reduce people's creativity. And it can be, in that respect, an unequal partnership between the strong members of the consortium and the weaker members who are somewhat marginalised to the background. But despite these problems, collaborative research is increasingly attractive and increasingly common. We'll talk about the European model because it has sort of become the standard model of how to collaborate in research, and it certainly is one of the most widely disseminated models in the entire world. And it comes straight out of the Directorate General for Research and Innovation, which is located in a particular part of the eastern centre of Brussels in Belgium, and which masterminds Horizon 2020, the current 5-year research programme, which ends in 2020 and is currently funding more than 80 billion euros worth of research. So we have two main points of reference there in a physical geographical sense. One is in eastern Brussels, quite accessible by metro from the main train stations. The other is just south of Gare du Nord, in a place which is somewhat confusingly called Covent Garden, which is, however, simply a tower block made out of glass, where a great many of the European Commission's research-related functions are carried on. So we started with the European Community Framework Programme for Research, Technological Development and Demonstration, and we ended up with the 6th iteration of the framework programme, which ran from 2002 until 2006. It had the objectives of strengthening collaboration in science and technology across Europe and to improve the international competitivity of Europe with respect to the rest of the world by promoting research and development in European institutions and also supporting EU policies to improve the lot of the European citizen. So FP6 was a large programme which was for research groups, companies, enterprises of various sizes from very small to not so small, public administrations at the local, regional and national level, students of various kinds right up to postdoctoral and early stage researchers, and indeed right up to the people who are top in their field, the world-class researchers who had their own special programme where they could try to obtain funding for further research with their own groups. And this also includes institutions with transnational research facilities, such as the European Commission's Joint Research Centre at Ispra, which is sort of in the province of Varese in northern Italy, not far from Lake Maggiore. In point of fact, it isn't in the province because it's EU territory and not Italian territory, and it does contain a nuclear reactor. FP6 also had some role for people not in the European Union as collaborators with European projects. Now, the Marie Curie actions, for example, are to provide training networks and support fellowships, which will give funding, in other words, salary, to early career researchers, such as postdoctoral researchers, so that they can travel to another country and work there for a limited amount of time. So these won't fund permanent positions, but they will fund a couple of years in a different country doing research. They will also fund some exchanges between institutions in different countries in order to broaden the international appeal of research. We moved from the 6th to the 7th framework programme, and in point of fact we're now in the 8th, but nevertheless the 7th framework was a little more targeted in as much as it had a lot to do with Europe's needs regarding improving the employment picture, the quality of life and competitiveness. So there's much research in FP7 on vulnerability and on pollution and on research and development of technology and so on. And the idea of FP7 was to optimise the research infrastructures of Europe on an international basis, crossing the national boundaries. Relevant themes from among many that were supported in FP7 were security and justice, which includes counter-terrorism, and natural hazards and climate change, where the emphasis in FP7 was on studying vulnerability, and a whole variety of projects were launched to do precisely that. The 8th framework programme is not called that, it is instead called Horizon 2020 because that's the year it ends in. And 80 billion worth of funding is supplied, in other words, funding has gone up. And the idea here is to improve research and development in industry, to face up to various societal challenges, including those connected with security, safety, vulnerability reduction, and the encouragement of resilience, and to achieve excellence in basic science. Now, the framework programmes have their supporters, and they've certainly done a great deal of good. Pardon. However, they also have their detractors, and there are criticisms or difficulties and drawbacks with them. For example, the administrative procedures tend to be very complex, and I can recall when we managed to get funding for a large multinational project, we had to fill in some 250 forms before we could get the money, and that took a lot of time and a lot of patience and a lot of effort. Then we have to wonder whether the framework programs actually do increase Europe's competitiveness and deliver excellence. Sometimes they do, perhaps, but sometimes one wonders. And whether, in fact, research isn't dragged down by too much of an emphasis on consortia and on the bureaucracy that consortia bring in their wake. But more than that, the emphasis on the applied dimension has tended to hollow out research in many instances. In fact, in some of the latest projects and programs, following the call for proposals, it is possible to do a literature search and on that basis develop some technology, apply the technology, that is to say, build the soft or hardware, sell it for the rest of the project by presenting it to stakeholders and so on, making sure it's used, and you have your project. But we ask in that, where is the real research? Where is the pushing forward of the research frontier? So, according to the EU model, regardless of exactly which programme we're dealing with, a fairly stable standard template or methodology has evolved for putting together proposals and getting them funded. Work packages containing work tasks are put together, and a typical proposal might include, for example, 7 or 9 work packages, occasionally fewer than that, dividing up the work into manageable units with particular durations. Project partner meetings and workshops, initially to kick off the project, finally to conclude it, and in the middle to assess progress and perhaps to disseminate it via stakeholder meetings and workshops. For example, I can recall when we were studying vulnerability, we invited stakeholders from various European countries to come to Salzburg in Austria, where we gave them a 2-day meeting explaining the advantages of using the methodology we'd developed in the project. Deliverables, mostly documents and reports and so on. Milestones, some of the documents, of course, might be publishable papers in journals. Milestones, the key points at which we achieve something in the project, which are due to occur at defined times within the project. A management structure with management reports to ensure the money is properly and fairly spent and that the project keeps on the rails and does what it says it's going to do. An advisory structure which can be either integrated into the project or outside it, of independent experts who can give advice on how to improve the project in a variety of different ways. And whatever the other outcomes are, whatever the deliverables amount to when we include the wider definition, such as books or reports or whatever. So to participate in a European project, or to start one off, one downloads the template, which is pretty long. It's a good 60 pages or more. And one starts filling in the blanks and adding the necessary parts to produce a full proposal. It needs to be done at least 6 months before the deadline, because this is a time-consuming and slow process with setbacks, because the next stage is to form a consortium, and many institutions or groups of researchers are wary of participating until they know the full story of what it's about and whether the consortium has a chance of succeeding in its application for funds. So eventually we'll have a proposal in draft form and we'll get our institution to clear it for submission. Indeed, the institution itself may submit the proposal, and it has to be submitted online before the deadline strikes, which is always on Friday at 4 p.m, probably about 6 months after the call for proposals is emitted, occasionally less than that. Then the research awarding body, the Directorate General for Research perhaps, will send the proposals out for review by experts who will evaluate the scientific worth, the value as applied science, in other words, pathways to impact, and the likelihood of success on the basis of the quality of the research and its relationship to the resources requested. So eventually, when the 15 points have been put down and we have all of the proposals evaluated, they can be ranked in terms of how many points the evaluators have given them. And by and large, if you don't get 13 points, you're probably unlikely to be funded. possibly 12, but rarely. So by and large, you've got to get more than 4, 4, and 4 in order for your proposal to be put forward for final evaluation, which means that you've got to hope that among the evaluators you don't get a nasty one who doesn't like your work or you, and that the consensus is that your proposal is an extremely good one. So it will be shortlisted if you're lucky, and then it will be chewed over by a team of experts who will spend about 4 days in Brussels working on a dozen or so proposals until they've finally reached a consensus on which is the best proposals. The winners will be informed and the losers. And there then starts a period in which negotiation takes place to finalise the contract by which the research will be done. And the proposal is transformed into a declaration of work, which becomes the legal document by which the research is funded and the work is done. Once that's over and the go-ahead is given, the starting date is fixed, we have a kick-off meeting at which we discuss the issues for the earliest part of the project, and then we simply get on with it. Very often the consortia will collaborate and communicate on a daily basis, such that all the time emails are flying around and work is being done in conjunction, often with the aid of Skype and things like that. When we get halfway through it, which will be 18 months in a 36-month, 3-year project, then there will be an evaluation, as there will at the end of it. There might even at the end be an audit by a certified auditor. And the question asked will be, has the project delivered on what it says it must do in the declaration of work? If not, then procedures will start up and there will be problems because the project will be in default. So, collaboration can increase the power and range of research and apply more resources to a problem because it enriches the team of people who are working on the research problem. But it does require great patience, much time and resources to manage the consortium or the collaborators well, bearing in mind that this requires a step change in the rate and level of communication, which often has to be over long distances about very complex problems.